3D rotation tool. 3D rotation tool is used to rotate our object in the Z-axis. Now, normally we can rotate our object only in X and Y axis, right? Well, by using this tool, we can rotate in Z-axis. What this means is we get all the views, like front, left, right, and back, in perspective view. In 3D terminology, rotating an object in 3D space is called a transformation. However, Flash allows us to create 3D effects by moving and rotating the object on the stage by using this tool. Select 3D rotation tool from the toolbox and press W, which is its shortcut. Now let's go to this tool with an example. Please note 3D rotation tool works only in movie clip symbol. Now, draw a star on the stage. Convert the star into movie clip symbol. Select the object, right-click, and we'll get an option box. In that, select Convert to Symbol option. Now another dialog box will appear. In that, type Name as Star. Type as Movie Clip and click OK. The object has become a symbol. Before selecting the tool, we'll discuss some important points about this tool. The default mode of the 3D rotation tool is global. We can toggle our object in local or global in 3D space. Local 3D space refers to the movie clip space. Now that means rotating an object in local 3D space is similar to rotating in its parent movie clip. Global 3D space is the stage space. Now this means rotating an object in global is the same as rotating in the stage. If we wish to rotate the object in local, select Global Transformation from the toolbox. Its keyboard shortcut is the letter D. Otherwise, deselect this option. Now select 3D Rotation tool, and this is the Global Transformation tool. Just press D. And here we get a bounding circle with 4 colors. In that, red indicates the X-axis, green is Y, blue indicates Z, and orange is used to rotate around the X and Y axes at the same time. Fine. Now, let's discuss how to rotate the object. Drag the X-axis controller. It will rotate in an up and down position. Next, we're going to drag the Y-axis controller. It will rotate in a left to right position. Lastly, we drag the Z-axis, and it will rotate in a circular motion. We can also move our control point anywhere, and we can rotate. Press twice in the control point to bring the bounding circle to the center position of the object. Now, this tool is very useful when we wish to rotate any kind of object in the entire axis. Hence, we have learned how to rotate our object in 3D rotation using this tool, and we've discussed about global and local transformation. 3D translation tool. So far, we've discussed 3D rotation tool. Now we're going to discuss the 3D translation tool. In 3D terminology, moving an object in 3D space is called a translation. But Flash allows us to create 3D effects by moving and rotating the object on the stage using this tool. It represents 3D space by including Z-axis to an object. Now next we'll go into this tool. Select 3D translation tool from the toolbox, or press G, which is the keyboard shortcut. And we'll move into this tool with an example. Please note the 3D translation tool works only in movie clip symbol, much like the 3D rotation tool. Place an object on the stage. Now convert this object into movie clip symbol. Select the object and press Convert to Symbol. A dialog box will appear. In that, for name, enter Pencil, and type must be movie clip, and then click OK. Our object converts to a symbol. Now before selecting the tool, we'll discuss some important points about this tool. The default mode of the 3D translation tool is once again global. We can toggle our object in local or global in 3D space. Local 3D space refers to the movie clip space. For example, moving an object in local 3D space is the same as moving in its parent movie clip. Global 3D space is the stage space, which means moving an object in global is the same as moving it in the stage. Now, if we wish to move the object in local, select Global Transformation from the toolbox. Its keyboard shortcut is D. Otherwise, deselect this option. Now go and select the tool from the toolbox, which is located under 3D Rotation tool. Now click on the object and we'll get X, Y, and Z axis, much like the 3D Rotation tool. Drag the object in x-axis. It will move the object in left or right direction. Similarly, when you move in the y-axis, it of course will go in the up and down directions. Next, the black point indicates the z-axis, where we can bring the object front and back. Please note, moving the object in z-axis will change those x and y positions. Now that is your 3D translation tool, and it's very useful to show our objects in camera view. Bone tool. Here we're going to discuss the bone tool, which is also known as the inverse kinematics. Let's discuss the use of bone tool and how it works. It is the process of determining the parameters of a jointed flexible object, a kinematic chain, in order to achieve a desired pose. Inverse kinematics is used to connect the bones while creating character animation. Now let's discuss this in detail, shall we? The characters in a game have skeletons which are similar to our own skeletons. This is a hidden series of objects that connect with and move in relation to each other. Using a technique called parenting, a target object is assigned to another object. Every time the parent object moves, the child object will follow, according to the attributes assigned to it. A complete hierarchy can be created with objects that have children and parents. Once the skeleton is created and all of the parenting controls put in place, the character is animated. Probably the most popular method of character animation relies on inverse kinematics. Inverse kinematics, or IK, is a method for animating an object, or set of objects, in relation to each other, using an articulated structure of bones. Bones allow simple instances and shape objects to move in complex and naturalistic ways with a minimum of design effort. For example, inverse kinematics lets you create character animation, such as arms, legs, and facial expressions, much more easily. You can add bones to separate symbol instances or to the interior of a single shape. When one bone moves, the other connected bones move in relation to the bone that initiated the movement. When animating, use inverse kinematics, and you need only specify the start and end position of the objects. Using inverse kinematics, you can create natural motion very easily. Bone tool allows us to connect virtual joints in an object. Its keyboard shortcut is the letter X. Now, as we grab one of the joints and move it, the object will move or animate with the other joints that we have placed. Now let's check all this out with an example, shall we? Select Brush Tool from the toolbox and draw an object. Then, using the Bone tool, we can attach joints from the top and bottom by clicking and dragging. Look here. Once we click on the object using Bone tool, it will create a new layer, called an armature. Armature contains bones that have relationships with other elements. Now that means whatever bones are created will be stored in armature layer. Now in our object, we have fixed bones, right? Well, to move the bones, we need to use Selection tool. Select the Selection tool, and we can grab any one joint and animate it such as this. Fine. Just look in the Property panel, and we can give instance name, specify location, and we have rotations, X and Y translation. If we disable this Enable option, we cannot rotate our joints. If we want to move in X directions, change here. If we wish to move in Y direction, make a change here. Now move to Stage. Here we select only one joint and moving, but it disturbs. Top joint also. To avoid this, press Shift key and animate, and we're able to move only one joint. Now in Timeline, go to the 35th frame in Armature Layer and right-click. We've got some options here. From that, select Insert Pose option. It's used to create a keyframe. Once we select this Insert Pose option, our in-between frames are highlighted with the green color. Now in this frame, give some animation to the object using the Bone tool. Very good. We've got some animation between these frames. Now just press Ctrl Enter to test the movie. All right. See, our character is animating. Again, go to Scene and save the document. Go to File and select Save. In the dialog box, choose Drive, right-click, and select New Folder. Rename as Bone. Good. Choose Type as Bone and click Save. The file will be saved. Hence, Bone tool allows us to perform animation, such as walking, fighting, cycling, and other human-related actions. Once well-versed with Bone tool, we can perform amazing stick animations as we watch them in Internet. Bind tool. In the previous lesson, we discussed the Bone tool and its uses. Here, we're going to discuss the Bind tool, which is related to that. Now let's discuss how this tool is interrelated to the Bone tool. Now by default, Bone is connected to the points which are nearest to them. The Bind tool allows us to edit the connections between individual bones and the shape control points. Let's start this tool off with an example. Open the Bone tool example from the save location. Now we've got an object on the stage. Very good. Select Bind tool from the toolbox, which is located under the Bone tool. Its shortcut is the letter Z. Once we select this tool, our object is covered full of control points. Now just look into the object and we could view the control points. Fine. Now using this tool, just click on the control point or bone. Wow. See, it's displaying the connection between the bones and the control points. Very good. Now similarly, if we want to highlight the control point connected to the bone, then click on the bone using Bind tool. Look here. The connected points are highlighted in yellow and the selected bones highlighted with red colors. If the control point is connected to only one bone, then it will appear as a square. If the control points are connected to more than one, it will appear as a triangle. Next, if we wish to connect more than one bone, press Shift and click on the bone. And if we want to remove a control point, then press Control and click on the control point. Next, let's move on to its properties. The properties of Bind tool are position and size. X position allows us to move the object horizontally. If we click and drag the value, the object moves in X position. Similarly, we have Y position, which helps us to move the object vertically. Now we've learned how to combine the control points of shapes using the Bind tool. Using the Bone and Bind tool, we can perform naturalistic movements with minimal effort.